gets me every time.
Welcome to Practical Hub channel. In this video, we will discuss about the single English, which is the fifth axis of the classical data structure. In this video, we will know about how to insert the node at the first in single English and the node at the last and the node at the particular position, and how to delete the node from any position. And next, to search the element in the single English and display. Display is nothing but the traveling the every node in the single English and display and presenting in the output. This is the basic structure of a single English. This is called a head, which is always pointed to the first, and we can call it as also a starting point, and it is a temporary node which will create when there is a use of it. And these are the addresses of the particular positions, and these are the positions. Now coming to the program, see, this is the single English program which I have written it in C. These two are the header files which are required to the single English program. Hash include stdio library.h is required to specify the functions like exit, such that. And this is the node structure of the single English, which has a next link node, and this is the value of that particular node. These are the functions which are used in this particular position, which represents what the work it is doing. And this create node function will return the node of struct node type. So there is a return type called struct node pointer, and these are the variables which are used in this program. And here the start will represent the always the starting position of a single English, and it will also known as head, and the last pointer will represent always the last of the single English, and such all the nodes which we are used as the temporarily in our program. Coming to the main function, here is the one variable I declared that it will use in the switch case, and while block is condition is always one, means it will execute infinity times until the exit case is called. And these are all the functions which I want to print in the menu. Printf function, which are always used to print the output. And this is the scanf statement that which will take the input from the user. That input has been taken as a input of the switch case. As switch case, take the input and select the case random. Select this case as per the input. If you give the input as a 1, it will select the node at the first position. Insert the node at the first position. 2 for the insert the node for last. 3 node at the particular position. 4 delete the node at a particular position. 5 search the element in the single English, and 6 to display, and 7 to exit from the program, and default statement. When we enter the ch value more than 5, then this function is printed. Now create node function. In this function, see, here the node is allocated memory dynamically, and the value of a node is assigned to it by the arguments, and always when the node is created, the next value should be null. And coming to the insert the node at the first position, and we always take the value which to be inserted, and we will call the create node function to create a node, and for after creating a node, it will return the node to the new node. Now our node is new node. Now it will check what the start position. If the starting position is null, there is no element in the single English. So the last and first will be a new node. If there is some element, means the start is equal to not and null. So the temporary variable should be taken, and the temporary variable is assigned to the start, means in the start we have an address. The address is assigned to the temp. Next, start is equal to new node, means start is equal to new node, and new here the start of next means new node of next is equal to temp, and next we will print that it is inserted. And now coming to the function node to be inserted at the last of the position. See, we are previously we are increasing the last pointer position also to indicate the last of the single linked list, because when we want to insert the node at the last, we want to traverse at the last of the single linked list. With the help of this last pointer, we can insert we can take that particular position from it and we can insert it. And here taking the value and the new node is created here, and the condition is checking that the start is equal to null. It is a single, it has a no node, so we create a node that is assigned. And next one is last. If there is no single linked list is not empty, then the last of the next is equal to new node, and last will be a new node. Last of next is equal to new node means last of next means the last position of null is always null because it is the last element. So the null value is replaced with the new node address. The new node address and the pointer should be updated to the new node. So these two you should note these two statements. And then inserted function is called. Next one, insert the node at the particular position. Here, these are all the variables which are used in these particular functions, and these are called the local variables, and we are taking the value as an input. We are taking the creating the node from dynamically, and this is the two statements are used to take the position from the user, and this is the temporary variable PTR, which is statically assigned to the start. Means it will here also PTR also is always assigned to the starting position. Now the starting position is a traversing pointer from the single linked list first position to the particular position, and here the PTR the variable used to take the traverse the single linked list from the starting position to last position of a single linked list. Here the while loop, when the pointer is equal to null, the while loop is executed. When pointer is not equal to null, the pointer position is updated to the next position of a single linked list. And here the count value, CNT value is incremented step by step. It will represent how many positions in a single linked list. Here, when the position of the node which we insert is equal to 1, it means the insertion of the node at the particular position is 1. So it is same as the insertion of the node at the first position, as we seen in the previous functions. And here, when the position is not equal to 1, here the pointer is assigned from the start, and the prev of variable is taken, which is the previously accessed by a PTR node. When the PTR is incremented, that is a previous PTR is at the position 2 and PRV is at the position 1, and we will find the particular position. If we want to insert the position at the 7th position, then the PRV is in the 7th position, and the PRV at the 6th position, and PTR will be in 7th position. Here the PRV in the 6th position next will be assigned to the new node, and the new node next will assign it to the PTR node address, and since the node is inserted, if we enter the range out of the single linked list, then it will present the out of the range, and read the position when here the variables, these are the variables, and the start equal to none, there is no element to the delete. So this will be executed, and if there is the node start is not equal to null, then we will take the input position input, and here also the PTR value is assigned from the start. If the start equal to null, and it is at the particular starting position, so at the start, that means there is only one node. While reaching the one node, while deleting the one node, the start is equal to null is represented. If there is more than one elements in a single linked list, we will found the position to be deleted, and then the position is founded by this while loop by incrementing the PTR. And while deleting, we want the previous node and the pointer node. When we want to delete the 7th position, the 6th position address value should be updated to the 8th position address. So here this statement is executed. PTR of next is equal to preview of next is equal to PTR of next. If the position is out of range, and this will be printed. After deleting, the PTR value is freed because of do not waste it of the memory. And while in searching, here the start is equal to none, there is no element to the search. And if it is not equal to null, we will enter the position array value to be searched. It will incremented until the position is founded. The PTR is initially assigned as the start, and it is if it is not equal to null, the for loop is exited, and while updating here is PTR is equal to PTR of next. It means it will increase the next position of a single linked list. And here position is equal to position plus 1, means the position is always to be incremented. And here if the PTR of value is equal to key value, that the single linked list value is equal to the what we inserted the value, then the flag is equal to 1 and break. It means it exited from the for loop. If the flag is equal to 1, the position is deleted. If it means the element is found and the key and the position is represented. If it is not found, then key is not found will be presented. The display function is very easy because just it is traversing and printing. Here if the start is equal to null, then there is no node in the single linked list, so it is represented. Otherwise, the for loop, the PTR is assigned. PTR is initialized to the start, and if PTR is not equal to null, it will execute. Or equal to null, it will exit the for loop, and the increment is the PRT is equal to PTR of next. So while traversing every node, we will print the node value. That is the program. Now we will run this program. Now at the output of this program, and under one, then I want to insert the node at the first position. Then it is asking the value of the node. I will insert 30. Second one is I want to insert the node at the end. Choose the second, and I want to insert the node 50. And next I want to insert the node at the particular position, so that I am choosing the key, and I want to insert the node 90. I want to insert the first, and let me display all these three. I insert the node at the first position and the T50. I want to delete the node. So I want to delete the node at the second position. As it is it is deleted. Let me display it. Yes, it is deleted. So next I want to search an element. So I want to search an element 90. It is said that the element the 90 is at the position. And let me display all this. Yes, the first position is 90 and the second position is 50. And let me exit. So this is the single linked list program. Hope you guys all this and understood and this, and thank you.